Okay, so this is a review for test 3. Use a graph of the parabola to fill in the table. Does the parabola open upward or downward? It opens down. Find the equation of the axis of symmetry. Now when it says equation, it's an equation of a line that goes through the vertex. Okay? And it's of the x value of that vertex. It hits the x-axis at 2. The equation, you must put x equals 2. That is the equation of a vertical line. If you just put 2, it's wrong. Find the coordinates of the vertex. Well, the vertex, it looks like it's 2, 1. I'm going to have a hard time fitting that in, but 2, 1. Let's just put it out here to the side. Find the x-intercepts, or find the intercepts, the x-intercepts and the y-intercept. There's always just one y. There's never two. Okay, so let's see. The x-intercept, it crosses at 3 and it crosses at 1. So it's rather 1, 3, or if you were going to write it as a point, or them as a point, okay, it'd be 1, 0, and 3, 0. And then the y-intercept looks like it crosses at a -3 or 0, -3. Find the x-intercepts and the coordinate of the vertex for the parabola y equals x squared minus 8x plus 12. Is there more than one x-intercept? Separate them. Yeah, if there is. Okay. Oops, and it would help if you could see it. There we go. Okay, so to find the vertex, it's x. To find the x value, it's -b over 2a. So that's going to be 8 over 2 times 1, which is 8 over 2, which gives us 4. That is how you find the x value of the vertex. Now to find, whoops, it would help if I could spell. You couldn't see that I spelled it. I put V-E-T instead of V-E-R. T-E-X. Okay. Now to find the y value, you just plug it in. Anytime they give you an x, no matter what it is, to find the y, plug it in. 4 squared minus 8 times 4 plus 12. This is going to give us 16 minus 32 gives us a -16 plus 12 gives us -4. Now, you could use your calculator, okay? You could say 4 store x and then plug in your x squared minus 8x plus 12, and we get -4. So that's the vertex. Now, to find the x-intercepts. X-intercepts have one thing in common, all of them. It's when 0 is our y is equal to, when our y is equal to 0. So now I'm going to put, I'll do that over here. I can do it down here. I have more room down here. 0 equals x squared minus 8x plus 12. Now you're just solving a quadratic. You can use square root property if it didn't have the middle term, but it does, so you can't do that. So you can rather factor. That's the first thing I'm going to look for, and it will factor. Then you could also, square root property, you could complete the square or use quadratic formula, but factoring is easier. So it's x minus 2, x minus 6. So then this gives us a +2. This one gives us a +6. So those are our two answers. Okay. All right, they give us this quadratic formula function. It says, does the function have a minimum or maximum? Well, You don't really need your calculator to find, to actually figure that out. You look at your A, it is negative, so it opens down. That means it has a maximum, okay? What is the minimum or maximum? So what is the maximum and where does the maximum value occur? Well, we can find that. I'm going to do that over here. Find our x value, which is going to be this. It's negative b over 2a. So that's going to be negative 24 over 2 times my a, which is negative 3. And I did not write my 4 there. Okay. All right, so again, negative b over 2a. I don't have you guys here to correct me, but I'm finding my mistakes on my own. Oh. Okay, so let me check it again. Negative 24 over 2 times negative 3. Okay, so negative 24 divided by negative 6, because I'm going to do this first, which gives us a positive 4. So it occurs at 4. Then what is it is your y value. So you plug in, remember f of x and y are the exact same thing. You're going to say negative 3 times 4 squared plus 24 times 4 minus 46. If this is how it was asked on your test, you are showing your work, okay? So always show your work. So 4 store x, even though I think that's left over, but from the last problem, negative 3x squared plus 24x minus 46 gives us 2. So again, if I was just finding the vertex, it'd be 4 comma 2. But because it's asking it in this for a maximum or minimum, and in this case it's a maximum, our maximum value is 2 and it occurs at 4. Now, yes, you can do this on your calculator to get this answer, even though I'm going to always do it by hand, but it's always good to check it on your calculator. Negative 3x squared plus 24x minus 46. I'm going to put it in zoom 6 and hope that it works. But there it is. Okay. And now to find that maximum, I'm going to hit my second button. I'm going to calculate second trace. And it's a maximum, so I'm going to hit 4. I'm going to put it on the left-hand bound, which it already was. I was looking at this number right here. So I just put it, I think it came up on the y-intercept, which was way down here. But anyway, put it on the left-hand side of that. Put it on the right-hand side. Put it up here in the where you think it is or close to it. Hit enter. You need to know that this is 4, but let's just double check. If I type 4, my y should say 2. And it did. Okay. The reason it's 3.999 is because it happens to be somehow where I put my cursors. Okay. All right. So that's how you fill that in. A ball is thrown vertically upward. Don't get confused because it's a word problem. You're going to read the problem so that you know what this is, the H is, and you know what T is. That's the whole reason you read these problems. It's just a math problem. A ball is thrown vertically upward after T seconds. So T is our seconds. Okay. Its height in feet, so this is our height in feet, is given by this function. After how long, so we're solving for t, will it reach its maximum height? Anytime you see maximum or minimum in a word problem, you're thinking vertex. Okay, so you're going to do negative b over 2a to find our x value. And in this case, This is where x usually is, so I'm going to call it t now. It says do not round your answer. Okay, so we have negative b. Now this is kind of switched up from what we are used to, but b is always what's in front of just the x or the t. So it's going to be negative 56. I could rearrange this and put negative 16t squared plus 56t. Okay, that was negative, so I made sure I kept it negative. This is positive, so I put a plus sign. So now, it looks like a decimal point. So now this is my a, this is my b. Remember, it is ax squared plus bx plus c. So b is always what's in front of just your plain x. Okay, so we have negative, it was positive, so when I fill it in, it becomes negative, over 2 times my a, which is negative 16, because a is always in front of my t, my variable squared. Negative 56 divided by negative 32. That's going to give us a positive, okay, and 8 goes into both of them, so 8 is going to go into 56 7 times and into 32 4 times. And that would be, okay, you can leave it as 7/4, but this is a word problem, right? And by the way, if you didn't know that that reduced to that negative 56 divided by negative 32 math fraction, or you can use your fraction key, you get negative 7/4. You couldn't see that, so let me do it again. Negative 56 divided by negative 32. I hit my math button. When I do that, it hits goes to that. And so it reduced it to 7/4. But because this is a word problem, can I take 7 divided by 4 and it end up with a terminating decimal, which it does? This answer is fine. It's actually a better answer when we're dealing with seconds. 1.75 seconds sounds better than 7/4, or even 1 3/4 of a second. Okay, any of those answers, all three of these are right. So, okay. The graph of the function with the vertex -2, -4 is shown below. Okay, so this point right here is -2, -4. It says write the domain and range using interval notation. Well, domain is all our x values. This is a quadratic. The domain of all quadratics are -infinity to infinity. Because we're not dividing by 0, it looks like this: ax squared plus bx plus c. There's no dividing by an x, which we have to worry about it being undefined, and there's no square roots. So we're not breaking any math rules, so it's always -infinity to infinity. Now the range is our y. Our y value, the smallest y value, is -4. And it goes to infinity. So it is going to be a bracket -4 to infinity. And it's a bracket because you have a solid circle there. You don't see an open circle. So there's a point at -4. It's actually the vertex. Okay, so find the range of the quadratic function here. Now again, the range comes from the y value of the vertex. So right here, I'm going to find the vertex. Okay, so, and I also, there's a +1, so I know the a is +1, so it opens up. Okay, so I know we're going to have a minimum here. So x is -b over 2a. Notice I rate that every time so I don't forget it. -6 times 2, or over, let's try that again. -6 divided by 2 times 1. So I have -6 divided by 2, which gives me -3. Now I'm going to plug that in to get my y value. Negative 3 squared plus 6 times negative 3 plus 7. So this is 9 minus or plus a negative 18. Doesn't really matter how you write that. This gives me a negative 9 plus 7 gives me a negative 2. So this is a vertex at negative 3, negative 2. Now I could have stored negative 3, okay, stored that under my x, because if you do not put this in parentheses, you're going to miss this problem and do x squared plus 6x plus 7. And you'll notice that it gives us negative 2. Sorry, there's a glare from my office light. Okay, so for the range, negative 2 is the smallest y value, so our range is negative 2, and it goes to infinity. Because again, I could graph that. Negative 3, negative 2, so it'd be somewhere right here, and it would go like this. I don't really know what the rest of the graph looks like, but I don't care because I'm just worrying about my y values. Okay, and I know you'll have one like this on your test. All right, vertex form. It says find the equation of the quadratic function g. Okay, so they've called this, I hope the rest of them were f of x, as I just was assuming. G, whose graph is shown below. Okay, so here's the thing. In vertex form, it is a parentheses x minus h, which that's your x value of your vertex, plus k, which is your y value. And let's just change this actually to a y. Okay, now you got to understand, x and y are just all the different points on this parabola here. So, we do not know the a, we have to find it. Now, you have to know which of these points is your vertex. Vertex is your minimums or maximums. So I'm going to take it, okay, first of all, I'm going to put in a 4 for this h. So let me just rewrite this. X minus 4, don't forget about the squared, plus k. K is our y value, it's negative, so I'm going to put minus 5. You could put plus a negative 5, it would be the same thing. Well, we have 3 missing things, and we can't deal with that. We have to only have 1. Well, they give us this point. This is our x value, that's our y value. So I'm going to take out y and put a 3. I'm solving for a. I'm going to take my x out and put a 6. Okay, so 3 equals, this gives me 2. 2 squared gives me 4, so I'm going to write that as 4a instead of a times 4 because it's the same thing. Minus 5. Now I'm going to solve for a. I'm going to take this 5 to the other side by adding it. And I get 8 equals 4a. Divide by 4. And a equals 2. So what I do is I go right back to this problem here, and I replace my a with 2. Now it says to find the equation of function g, so instead of y, I'm going to say g of x is equal to 2 x minus 4 squared minus 5. And that is in vertex form. Let's try there. So all I did was I took this equation and replaced a. And I didn't call it y, I called it g of x. Okay, find all the zeros of the quadratic function. Well, zeros are x-intercepts. So that means our y is 0. So I'm going to say 0 equals x squared minus 18x plus 81. Well, I'm going to factor it. I'm always going to factor it if it factors. I rarely will ever use quadratic function. The only time I will use it is if it doesn't factor. Well, this is going to factor as x minus 9, x minus 9. So I set each of these equal to 0, and I'm going to get x is equal to 0. Let's try this again. 9. And here I get 9, but I only need 1. So I only have one 0, which is 9. What this is going to tell us, I know this has a degree of 2, okay? So at most it has 2 answers. These do have 2 answers, it just happened twice, it's the same thing. So it's going to open up down here at 9, it's going to come down here, touch this, and bounce back because it has a multiplicity of 2, because there were 2 of them. Because I could have written this as 0 equals x minus 9 squared, but it doesn't really matter. I get the same thing. Okay. For each function, determine whether it's a polynomial function. Basically, for this problem, you do not want negative exponents. You do, because that means you'll have an x in the denominator. Okay, so you don't want x in the denominator, you don't want negative exponents, you don't want square roots. So this is a function, because we're not dividing by 0, we're dividing by 8, that's fine. This is a constant, so it's a horizontal line, that is fine. But this has a square root, so that is not. This is fine, we're not dividing by 0, we can't divide by 0 in any form or fashion, we can't take square root, so that's fine. Other things that would not be would be something that looks like this, x to the negative third, and that's because you can rewrite that as x to the positive third. I'm sorry, x divided by, let's try this again. X to the negative third is the same thing as 1 over x to the third, because again, we don't want negative exponents. If x is 0, that's going to make this undefined. Okay? All right. This one right here. Find all zeros of this function. The nice thing about this is it's in factored form already. Okay? We don't have to do the factoring. So any of the factors that have an x in it, you set equal to 0. So we have negative 2x is equal to 0. You have x squared minus 16 equal to 0. And you have x squared plus 49 equals 0. Okay? Now, right here, I'm going to divide by negative 2. And I get x is equal to 0. That one's good. This one right here, you can do it one of 2 ways. You can use square root property because there's no bx, there's no middle term. So you can take that 16, that negative 16, over to the other side, and you get a positive 16. Then take the square root of both sides, and because we put that square root symbol in there, your answer is a positive and a negative 4. Now, the other way you could have done it is factored. X plus 4, x minus 4 equals 0. Here it's going to be a negative 4. Here it's going to be a positive 4. So we still got a positive and a negative 4. Right here, it won't factor. The only way you could do this is take that to the other side, and you get x squared equals a negative 49. and then take the square root of both sides, but in our class, we do not deal with this. We don't deal with negative square roots. Those of you that know, it would be a positive and a negative 7i, but we don't deal with it. So this is, and we are only finding real zeros, okay? This would be imaginary, so we don't have to worry about that. So the real zeros, I'm going to put them in order: -4, 0, and a +4. I just put them in order, that's it. Okay, suppose that the polynomial function is defined like this. List each 0 of f according to its multiplicity in the categories below. I don't have any categories below, but anyway, so here's what we're going to do. Let me check something. I'm going to check my answer sheet really quick just to make sure I'm not missing something here because of the categories below. Usually you have a list of multiplicity of 1, 2, okay. Yeah, it's right. I was just thinking maybe my thing didn't print out. Okay, right here, x is going to be equal to -2. Right here, x is going to be equal to -5, and here, x would equal to 9. If you don't know how we do this, just set each one of these equal to 0, just like we did up here. Okay, so we have -2. It has a multiplicity of 1, because this has an exponent of 1. We have a 0 at -5 with a multiplicity of 1. And then we have a 0 at 9, and it has a multiplicity of 3. Okay, now on each of these, what that says is all of them cross the x-axis. Okay, they all cross the x-axis. This one just kind of crosses, it kind of snakes through. I don't know if it's going to go bottom to top, but it would go more like this, where these would just go like this or like this. I don't know what, I could figure out what this looks like. I would know what it looks like because this is an x. If I was doing ending behaviors like we're going to do down here, I would do the leading coefficient test by saying x times x, and this one would be x to the third, which this gives me x to the fifth when I multiply that out. It has a degree of 5. That means it's odd. 5 is odd, which means the ending behaviors go different directions. The leading coefficient is 1. That means the right side goes up. And that's because it's not because it's 1, because it's positive. Okay, so if we were to just do a really, really, really rough sketch, okay. Okay, so this is +1, so this right side goes up. They go different directions, so the left side goes down. Okay, I have one. It's got -2 here. Let's say -5 is here, and we'll do 9 is way down here. Okay, so how this would look is it comes up to 5 because it has a multiplicity of 1. It goes through the x-axis. It comes someplace up here, turns around, comes back down here at 2, and it has a multiplicity of 1, so it crosses, comes somewhere down in here, turns, comes back to 9, and it kind of snakes through because it's still odd, so it snakes through and goes up. See the difference? Okay. It's just a little flatter where these aren't. Okay, so that's basically how you would use multiplicities. All right, choose the ending behavior of the graph of each of the polynomial functions. Okay, odd degree, they go different directions. This is positive, so right side up. Okay, so on the left side, okay, so if I was going to, because it just helps me to do this, the right side goes up, the left side goes down. Or, like if this was your test, you could just do this. I would be good with that, okay? So it falls on the left and rises on the right, to the right. Right here, this is even. So they're the same direction. They rather both go up or both go down. This is positive. So, again, you can deal with the right. It goes up because it's positive. Well, because it's an even function, they both go up. Or you could just do it as simple as this. I'm good with that. Okay? Rises to the left and rises to the right. And then this one right here, multiply this out. Okay, this is a negative 3x times x times, if I multiplied this out, it'd be x squared. So that is negative 3x to the fourth. Same direction because it's even. Both go down because that's negative. Okay, so on the graph it would look something like this. Now for me it could be as simple as just that, okay? But falls to the left and falls to the right. Okay, I think there's one more for this video. Consider the following polynomial functions. Okay, so we actually have more of the graphs in this. Oops, well, oops, I had to do, I think I have it over here on the printer. There it is. Okay, now, the way I do this is I first start with the leading coefficient test, okay? The leading coefficient test for g, let's talk about g of x over here. It's x to the fourth minus 9x squared. Okay, so leading coefficient test, you're going to deal with this one right here, okay? It has a degree of 4. It's even. Tells you that means they go the same direction. Okay. The leading coefficient, leading coefficient is positive because it's positive 1. Because what we're doing is we're dealing with the leading coefficient test. We are only dealing with the 1x to the fourth. That's what we're talking about. Okay. So the leading coefficient is positive, which means they're both going to go up, or the right side's going to go up. Okay, so first of all, it could be D, can't be this one, it cannot be that one, can't be this one. It could possibly be C. Okay, so I've narrowed it down to these two right here. Okay, now let's look at the difference in them. Well, this one we've got x-intercepts at negative 3 and 3. Same thing here. Okay, the y-intercept, that's the difference in these. This one's at 0, 0. This one, and it's also a 0, right? Because that's a 0. Here, it's 0, 4. So there's a couple ways you can do this. Because I noticed this, what I'm going to do is factor this. I'm going to find my zeros. Because if a 0, I'll find my zeros and I'll explain. So that means I'm going to say 0 equals x to the 4th minus 9x squared. I'm going to factor out an x squared, and I'm left with x squared minus 9, x squared, x plus 3, x minus 3. That tells you that x is 0. Here, x is a negative 3. And here, x is 3. So that means it's this one right here, because this one doesn't have a 0, 0. Okay, only this one. So for this one, it is graph D. Okay, now this one right here, the h of x. Again, I'm going to do the leading coefficient test, which means I'm really only, you can distribute, it's fine, but the leading coefficient test is going to be from this, the negative 2x times x squared, which gives us negative 2x to the 3rd. The degree is odd, so they go different directions. This is negative. Our leading coefficient's negative, so it's down on the right. So basically, okay, it's down on the right, up on the left. Okay, so let's find our graphs. It's not A. It could be B. Okay, I'll just circle that. It can't be C. We know it can't be D because that was the other one. Can't be E because that one's down on the left, up on the right. But it could be F. Okay, so it's between B and F. Well, let's look at the difference. This has a 0 of 0 and 3. This one has one of negative 3, 0, and 3. So let's find our zeros. Well, this is already factored for us, which is good. So we have, well, it's partially factored. We have negative 2x, but this factors as x plus 3 and x minus 3. Well, that has an x in it. So this here, if I set this equal to 0 and solved, I'd get 0. Here, x would be negative 3. Here, x would be 3. So that one would have to be this one, because this does not have a negative 3. Okay, it does not have a negative 3 like this here it is. Okay, so graph B. Okay. I will do another video for the next ones.